Hello everybody and welcome. Today I wanted to talk about something that every teenager is getting interested in sooner or later. It is about love. Here, however, I'm not interested in bringing you yet another probably most boring advisor clip on this topic, meaning I'm definitely not trying to give you hints about finding and attracting the right partner for you. Instead, I'm interested in the question whether there exists a mathematical description of this funny thing we call love. Does this mean one day we will be able to ask our computer about how to get the most attractive element in your vicinity? Well, you're going to see. So, without further ado, let's get right into it. At first I did some digging, which in my case just means that I asked my father about this love stuff. The interesting thing is that he had just written a book with the promising title, Mathematical Psychology, Tools for the Understanding, Simulation, Mitigation, and Potential Prevention of Mass Formation Psychosis. And he explained to me that, in principle, everything I would need in order to develop the right math for this love topic of mine is to be discovered in that book. The reference can be found in the video description and at the end of my presentation. And how does love look like with this math? I asked my father. Well, it looks like quantum fields, like those orbitals the electrons form when being bound to a proton and when electron and proton are becoming manifest as an atom. In this picture, individuals are the protons with halos around them describing the fields of individuality, and when these fields entangle with the fields of other individuals, the whole can become an interaction. A love field, I asked, and when my father answered yes, I knew what title I would use for my presentation here. What I've learned from my father then is that actually the mathematical task of starting the modeling of love is not very complicated. It is more the complexity of the model which then makes things difficult. But let's ignore this little snag for the moment. Our starting point shall be a fundamental mathematical description of the human psyche. Thereby we walk the graph every clever clinical psychoanalyst would take when performing the anamnesis of a patient. We use a set of attributes, allocated them to the human being, and try to adjust the attributes or properties scale to our observations. This set of attributes, then describing our individual, is mathematically forming a space-time, and by assuming that this space-time is A. of Riemann character, B. has to be subjected to a Hamilton extremal principle in order to allow the object or system described by respectively residing within the space-time to exist in a universe governed by external principles. We simply require a mathematical apparatus which can handle arbitrary and rather general ensembles of attributes. This apparatus already is at hand. It was introduced by David Hilbert in 1915, and it directly leads to the so-called Einstein-Hilbert action. And now comes some complicated math. I therefore just want to read from my textbook. Solving the corresponding variational problem gives generalized Einstein field equations, the mathematical foundation of the general theory of relativity. The equation, most interestingly, also contains something one does usually not connect with Einstein's great theory. The attentive viewer will have already realized that these equations do not only contain the full theory of general relativity, see the red ellipse, but lo and behold also include all main quantum equations, be it for bosonic or fermionic entities. The whole ensemble undoubtedly has the characteristics of a quantum gravity theory. And the best part of it is, it was already there for about 107 years in a paper from the great mathematician David Hilbert. Only that neither Hilbert nor Einstein had a chance to see it, because the more advanced mathematical quantum theory came over a decade after the general theory of relativity, and then the theoreticians were so overwhelmed by the new quantum theory that nobody, at least so it seems, ever looked back at the old Hilbert work from 1915. We see that it seems to be that what classically in quantum physics is been known as the wave function makes out what we see as individuality. The subsequent recipe one can extract from this equivalence regarding one individuum does seem to lead to some kind of molecular dynamics, though they are very multidimensional and complex when considering ensembles of individuals. Thereby we can already quite easily imagine how the fields of dominant, omnipresent individuals would look like in comparison to some timid, recessive ones. Now I want to discuss the above introduced math in connection with a form of interhuman interaction we all know as love. For this I will use an illustration of the conflict-prone situation I had found in this book here. The reference will be given in the video description and at the end of this presentation. While the book is about an evil, completely selfish womanizer character who likes to destroy otherwise intact and happy families, here I want to keep the interpretation of the love fields simulation more general. And here we go. On the left, the aloof attractor. On the right is an intact family cell. For various reasons, one of its members is a little off to the side. It is this small individual field on the top left of the family cell. I marked it with a small red ellipse. This outsider of the otherwise intact family feels itself attracted to the new entity, the attractor. Here, the outsider is already leaving the safe family shell and is literally pulled in by the attractor. Subsequently, now we see how the outsider is moving over to the attractor and into his or her trap. The moment the distance is just right, the attractor snaps the isolation trap shut and binds the outsider to himself and thus his or her misery. Due his actions, the attractor will also have destroyed the previously intact and happy family. There are many more love field constellations and examples, also including tribal and group behavior, my father and his team have calculated. They are also working on better ways to present the love fields and the interhuman interaction. This is quite complicated because the interaction are of extremely high dimensionality. So I think that I'm planning to give another presentation about this topic rather soon. Until next time, I see you, bye bye.